All right, we're going to take a look at some problems from 1.5. So have your notes that went along with 1.4 out for 1.5. Kind of want to hit the high points here. There are some definitions that I'll let you kind of look at on your own, and we'll cut to the chase of the meat and potatoes. Um, this is going to be especially important, the second one. So back to regular old algebra solving. We're going to solve for y. So if I had to solve this top equation for y, the first thing I would do is add the 1 over, and the second thing I would do is take the square root of both sides, not forgetting that it's a plus or minus. So my answer is y equals plus or minus the square root of x plus 1. This is going to be a skill that will be used when we're solving this stuff. Now this next one is going to be the big one. This is the big thing that you're going to have to do when doing this lesson. If I'm going to solve this for y, the first thing I need to do is get it out of the denominator, or get y plus 2 out of the denominator so I can work with this thing. So I now have x times y plus 2 equals y plus 1 because I got rid of those ones over there. The next thing you're going to do is, if you're solving for y and I have 1 over here and 1 over here, I do need to distribute this x. So I get xy plus 2x equals y plus 1. And then I still have two y's. How do you turn two y's into one y? Well, you move the 2x over here. I move the 1y back. So what I'm doing is I'm getting the y's, the two y's, on the same side. And it will hopefully become slightly clearer as to why here in a minute. That was a joke. So I got a y, two y's over here, and now I can factor a y out, and that's going to be your ticket. This is the ticket. Y times x plus 1 equals 1 minus 2x. And now I've gone from two y's in the original problem, and I got it down to where the factoring out gets it from two y's to one y, and that's the big moment that things are going to happen. And this is going to help us when we have to solve for our solving these inverses that we're about to do. So my answer, going from this original problem up here down to solving for y, going from two y's to one y, the moral of the story is you got to get the two y's together on the same side with nothing else so you can factor out. That's the whole key for what we got going on here. So the first thing is, it came up at the end of 1.4, a relation is any set of ordered pairs. Now, if we want to find the inverse of a relation, all we do is we take the ordered pairs and change the x's to the y's and the y's to the x's. It's that easy. The big thing here is we call an inverse, this f to the negative 1 is read as f inverse of x. So when we're going to be calculating inverses of functions here, and it's not f to the negative 1, and this negative 1 does not mean put it into the denominator like a negative exponent means. It means f inverse. So when we're talking about the inverse of a function, we write it as f inverse, or if it's g of x, it'll be g to the negative 1, and we read it as g inverse. Horizontal line test, we'll take a further look at this in class, but if you have the vertical line test, if you remember back to the vertical line test, let's say, for example, y equals x squared. If I have y equals x squared, and that is a function, it's a function because the vertical line test passes. Now, if I run a horizontal line test and do the same thing that we did with the vertical line test, I run into a problem as soon as I get up here where I run into 2 points. So the horizontal line test fails. we're going to run the horizontal line test to see whether or not the inverse of a function will also be a function. And I know that's a lot to wrap your head around, but we'll get there. It'll be okay. So y equals x squared is a function. Yes, it works out well. Y equals x squared's inverse is not a function. And we're going to see why. So we would call that y inverse is not a function because the horizontal line test fails. So what's an example of one that passes both the horizontal line test and the vertical line test? Well, think about y equals x cubed. Y equals x cubed goes like this. I run a vertical line, I pass, I'm good to go. I run a horizontal line, I'm good to go. And we call that 1 to 1. It's 1 to 1 because every x goes to a unique y, every y goes backwards to a unique x. And if you think about up here, you don't have to go any further than 2 squared is 4, negative 2 squared is 4. 2 and negative 2 are dancing with the same partner, whereas when we're talking about down here, everything has its own partner when it comes down to the ordered pairs. If I want to state the points of f inverse here, it's as fast as flip them around. So this is going to be, I change them from x's to y's, y's to x's. That's what we're doing when we're doing an inverse. And this is a relation. Now, if we examine this relation very closely, negative 3, negative 2, negative 1, 0, 1, that has to be a function. I'm not even worried about what the y coordinates are. Again, when I flip them around, now I'm worried about the x's, 4, 1, 0, 3, 7. I didn't say anything twice. So in this case, this relation is a function. Its inverse is also a function. So when you're talking about the relation as a list of ordered pairs, you're only talking about flipping the x's and the y's. Now, when we're going to do it algebraically, so this is the big thing, this is the big calculating an inverse algebraically. There's going to be, I think there's 4 steps. Step 1, we rewrite it, we change the f of x into a y. So I have y equals 5x plus 7. So we're in function notation. We need it in y equals notation. Step 2, interchange the x's and y's. And that's the same as flipping around the ordered pairs, which is what we did on the last screen. So instead of y equals 5x plus 7, I have x equals 5y plus 7. This is changing all of the x's and y's in the entire function, which is an infinite function. The domain is negative infinity to infinity. It's going to go on forever. So now I've changed them around. 3, I solve back for my new y. So I solve for the new y. New. So I have x minus 7 equals 5y. Divide by 5. Divide the whole thing by 5. Remember all your rules. And then y equals x minus 7 over 5. And the last thing that we have is change that new y to f inverse or g inverse, whatever your function was. And I always like to put it back on the left because we live in America and we read from left to right. X minus 7 over 5. So my original function of 5x plus 7 has an inverse of x minus 7 over 5. So these 4 steps are going to be what you need to write down and what you're going to be doing each time we're doing when it asks you to find the inverse algebraically. So now you go back to that original screen that we did. What did we do? We started with y equals x squared minus 1, and then they interchanged it. So we were practicing the skills of solving backwards. And then this started out probably as y equals x plus 1 over x plus 2, and now we switched them around and solved backwards. So that's why we did those skills when we get to one like this. And now the next one is going to be the big picture. So again, step 1 was going to be change it into y. Step 2, interchange the x's and y's. Step 3, solve back for y. In this case, I need to multiply both sides by y minus 1 because I'm getting it out of the denominator. Again, what are we trying to do? I got two y's. I need to get to one y. We're going to work towards getting them on the same side. I'm going to go ahead and distribute that x right now. Xy minus x equals 2y. Next, move this x over here. Move that 2y over there. I have xy minus 2y equals x. So I added this x over. I subtracted that 2y back. We're almost done. Factor out a y and divide. Whoops. And we're left with y equals x over x minus 2. The last thing we have to do is we were trying to solve for f inverse, so I do need to change that y to f inverse of x equals x over x minus 2. Calculating an inverse algebraically, we got this guy is the original and this guy is the inverse. I know I went kind of quickly on that, but you can watch it again on Schoology if you so choose. The moral of the story is interchange the x's and y's and solve back. There will be some practice on this in your homework as well. Real quickly, a function and its inverse are reflected over the line y equals x. So you can take a look at this on your graphing calculator. If you put in, say, y equals 5x plus 7 and y equals x minus 7 all divided by 5, watch your parentheses. And then if you put y equals x, it will split it right down the middle. Same thing, this is going to be, these are going to be both going to look like the inverse functions, but they are split by the line y equals x. So they're going to be reflections of the line y equals x, and it kind of goes back to the y equals e to the x function that we graphed, which looked like this, and y equals ln of x function, which looked like this. And if you put those two on the same one, they're reflected over the line y equals x because they're inverses of one another. And then the last thing, they're going to ask you in your homework as well, check to see whether or not, or show that these are inverses by using composites. Remember, if you're a composite, you're doing f of g of x and g of f of x. And every time you do a composite with an inverse, you will get x. It will come out to be x every time that you do it. So if it says show algebraically that this function and this function are inverses, what we're going to do is f of g of x, and this is where I'm going to put the g function right in here. I'm taking this guy and putting it in there. So I have the cube root of x minus 2 all cubed plus 2. So this function went into the f function, and now what happens when you cube a cube root? Set me free. It gets set free. X minus 2 plus 2 minus 2 plus 2, boom, x. We just showed that f of g of x is equal to x. And if we went the other direction would be g of f of x, which means I'm taking the f function and shoving it into the g function. So I have the cube root of x cubed plus 2 minus 2, and you can see them getting undone. 2 minus 2. I get the cube root of x cubed, which is plain old x. So when they ask you to show by using the composition of functions that two functions are inverses, you are doing f of g of x and it comes to x, g of f of x comes to x. I foresee in your homework where they will ask you, tell whether or not these are functions by calculating the compositions. Some of them will not come out to x, and if you don't get x when you put them together, they are not inverses of one another. You could try those other two that we just had. I believe one of them was 5x, was it plus 7, and then we had its inverse was x minus 7 over 5. And you can almost see it. Put the 5x plus 7 right in here. The 7's cancel out, 5x over 5, boom, done. If I put this up here, 5 over 5 would be canceled out, x minus 7 plus 7, and we're good. So the linear ones are much easier to see than the more difficult ones. We will take a look at doing the composition on one like this. I think they ask you to do these ones. There's a little bit more involved with those, but they definitely can be done. I look forward to it. Enjoy your time working on these inverses. The algebraic is the big picture for today.